Hi, welcome to this video. I'm just looking down at the screencast thing and like they've changed all the stuff that at the bottom and it threw me off. But anyway, let's do this again. Okay. Anyway, so we're going to look at triangle classification and we're going to actually use that to combine it with what we know about about triangles and also what we know about equations. So we're going to be kind of tying some things together today. First of all, as you look at the drawings here, number one, it says circle all the acute triangles. So in order for a triangle to be an acute triangle, it would have to have all of its angles less than 90 degrees, so between 0 and 90. So if I look, let's say, for example, this first triangle here, this purple one, two of its angles are acute. But that's not enough for it to be an acute triangle. They all have to be acute for it to be an acute triangle. So that's why I would circle this one, because all three of these angles are less than 90. And all three of these angles are less than 90. Now, this one's tricky because it doesn't tell us the angle measurements. Now, I know the angle measurements because I know it's an equilateral triangle. And if it's equilateral, it's also equiangular, meaning that if all the sides are equal, then all the angles are also equal. And I also know that all the angles add up to 180. And we'll be talking about that soon. So I know that they all have to be 60. But maybe you didn't know that. So maybe you're just going off of the picture. And yeah, that's also an acute triangle. So from there, number two says circle all the scalene triangles. Well, now we're only identifying the triangles by their side lengths. Scalene, if you remember from last week, means that all the side lengths are different sizes. So I'm just looking at the numbers themselves. For example, this purple one, that's equilateral because all of them are the same number. And the gray one, that's isosceles because two of the sides are equal. So if two of the sides are equal, it's isosceles. If all the sides are equal, it's equilateral. So if it's not those two things, it has to be scalene because you have to have all three different numbers. So I know it's that. So now we're going to put the two things together. We're going to look at sides and angles and look at a very specific triangle, like one that's obtuse and isosceles. So pause this video and see if you can circle any of the triangles that are obtuse and isosceles. Okay, so I'm assuming you're back. I'm going to start with the ones that are obvious, like this one here. I noticed that this purple angle is greater than 90, and two of the sides are 5. So isosceles means two equal sides. Obtuse means it only needs to have one angle more than 90 degrees, and it does. So the purple one is it. When I look at the others, well, I know it's not this one because even though it's obtuse, I know it's not this green one because it's obtuse, but it's not isosceles. And this one isn't any of those things. It's right and it's scalene, so that's out. So now I get down to these other two. They don't have side lengths on them. So how do I know? Well, these tick marks tell me that these two sides here are the same length. So if the two sides are the same length, then that means it's isosceles. So it didn't tell me the side lengths, but it's telling me they're the same length because they each have one tick mark in them. It also has an obtuse angle, so it's obtuse and it's isosceles. The first triangle here pictured is isosceles, but it's not obtuse. It's acute, so it's out. So we had two that were obtuse and isosceles. So that's a review from before. Now what we're going to do is apply that concept of having a of the side lengths being equal to equation solving. So you're going to see we get real complicated. So let me do the easy ones first as instruction, and then I'll pick some of the more difficult ones, and then we'll talk about how to do them. Okay, so number 4 here. Come on now, come on. Where'd you go? Where'd you go? Sorry, that's getting you dizzy. Boom. Okay. It's presenting a right triangle, and it's saying that it's a right triangle. I have a right angle here, and then it's also isosceles because these two sides are the same. says write an equation to find the value of x, then find the missing side length. So the side length down here, which is actually called the hypotenuse, but you don't need to know that, is about x plus 1.24. I don't know enough yet to be able to find that by itself, but I can say if I know these two sides' lengths are equal, then that means that x over here, this side, has to be equal to the other side. So x must equal 3. So there's my equation, x equals 3. Well, if I know x equals 3, because both these sides are 3, then that means I can substitute this value in for x because there's the same x over here, and I can say, now 3, so I'm going to x plus 1.24. That's the last side we don't know. So I'm going to substitute in 3 for x, add 1.24. So that means the third side must be about 4.24 units. So this is 3 units, and this is 4.24 units. Okay. So now let's look at this next one. Well, in letter B, we forgot to put in the directions that this is actually isosceles. Sorry. So if that's isosceles triangle, then that means that this side here equals this side over here. So now 8x equals 45. 45. Sorry. So now I have to solve this to find out what x equals. So I'm going to divide both sides by 8, and I get x equals 5 5/8. So that means that in order for these side lengths to be the same size, x must be about 5 5/8. So that means this side here isn't 5 5/8. This side is 45 units. X is 5 5/8. So what does that do for me? Well, now I can substitute in x here and say that 5 times x plus 2 is the length of the third side. So I'm going to substitute in my x value, to find my last side. And I get 30 1/8 units. So that means that this side here will be 30 1/8 units. And as I look at that, I want to think to myself, does it make sense that that side's shorter than the other two sides? Well, it looks like it should be shorter, so it kind of makes sense. So I think I'm good. So there you go. Those are the easy ones. Now let's look at more challenging ones.